Hello everyone, myself Ankur Patel, and today in this sixth session of projection of lines, we are going to discuss problems in which midpoint of the lines are given or a point in between the endpoints of the line at some ratio are given. So let's start with the practice problem 1. A line AB 80 mm long is inclined at 45 degree to HP and 30 degree to VP. Its midpoint C is in the vertical plane and 15 mm above HP. The end A is in the third quadrant and B is in the first quadrant. Draw the projection of the line. So the given data is a line AB 80 mm long. That means the true length of the line is 80 mm. Is inclined at 45 degree to the horizontal plane. So theta is 45 degree and 30 degree to the vertical plane. So phi is 30 degree. Its midpoint C is in the vertical plane and 15 mm above HP. So midpoint C is in the vertical plane and 15 mm above horizontal plane. The end A is in the third quadrant and end B is in the first quadrant. So end A of the line is in the third quadrant and end B of the line is in the first quadrant. Draw the projection of the line. So we have to draw the projection. That means we have to find out the plan and elevation length of the line. So here we can say that point A is in the third quadrant. That means it is behind VP, below HP. And point B is in the first quadrant. That means we can say that it is above HP in front of VP. And the length of line AB is 80 mm and C is the midpoint of the line. So we can say that the length of line ACB is equal to 80 mm. So if we measure the distance between C to B, it will be equal to 40 mm. So right now in this question, first of all we will find the locus of C and B, then after we will find locus of A. So right now we will consider length of the line is equal to 40 mm and we will draw the locus of C and B only. So let's start. So first of all draw XY reference line. Now mark the plan and elevation of point C. So C is in the vertical plane and it is 15 mm above HP. So C is in the vertical plane. That means whenever the point is in the vertical plane or the vertical plane, the plan of that point will be on the XY reference line. So XY reference line will be our locus of C and it is 15 mm above HP. That means 15 mm above the XY reference line we will get the locus of C dash, and on this locus we will get the elevation of point C. So first of all mark point C on the XY reference line, because we will get point C on the XY reference line because XY reference line is the locus of C. Now from point C draw the projector of point C. The intersection point of the projector to the locus of C dash will gives us the C dash. Now we have to find out the locus of B. So for that we will consider the length of the line is equal to 40 mm and the given angles are theta and phi. So the inclination of the line CB with the horizontal plane is 45 degree and with vertical plane is 30 degree. So as we know that we can draw theta angle from C dash. So from C dash draw a line having length 40 mm and inclined at an angle of 45 degree in upward direction, because right now we are going to draw the locus of B and B is in the first quadrant. So whenever the point is in the first quadrant, we will get the elevation of that point above the XY reference line and plan of that point below the XY reference line. So right now we will get the locus of B dash above the XY reference line. So from C dash we have to draw a line in upward direction having length 40 mm inclined at an angle of 45 degree. So draw a line having length 40 mm inclined at an angle of theta, which is 45 degree. So here we will get B1 dash, and this will be our locus of B dash and B1 dash. Now from C draw a line having length equal to 40 mm at an angle of 30 degree in downward direction, because we will get the plan of point B below the XY reference line. So here we will get B1 and this will be locus of B and B1. Now we have to find out here, we have to draw the projections. That means we have to find out the plan and elevation length. So if you want to find out the plan length, draw a straight line from B1 dash up to locus of C. Here we will get B2 and now take center at C. Radius is equal to C to B to give an arc on locus of B. So here we will get B. Connect B to C. This will be our plan length. But right now this plan length is half plan length because still we have to find out the locus of A. Now from B draw a projector of point B and we will get B dash on this projector at locus of B dash. So the intersection point of this projector and this locus of B dash and B1 dash will give us the B dash. Connect B dash to C dash, this will be our elevation line. But again, make sure that this length is the half elevation line, because still we have to find out the locus of A dash somewhere below the XY reference line. So this is the alpha angle of elevation line, and here will be the beta angle of the plan length. Now if you want to find out the locus of A, the length of A to C will be equal to 40 mm. So extend this C dash B1 dash line, because this is a two length of the line or half two length of the line, in the backward direction like this. So here we will get A1 dash, and this will be our locus of A1 and A dash. And from CB1, or extend this line CB1 in backward direction, having length equal to 40 mm. So 40 mm backward from C, extend this line in same direction at an angle of phi. Here we will get A1, and this will be the locus of A1 and A. So right now we have got the locus of A dash and A. Now as we have got the locus of A dash and A, we will find the total plan length and total elevation length. So first of all, extend this elevation, that is C dash B dash, in downward direction like this. So we will get the intersection of this line over here. So this will be our A dash. Okay. Now extend this half plan length in backward direction up to locus of A. We will get A over here. So this will be the plan of point A. And if we draw the projector from A, it will pass from A dash also. So these are our end projectors. The distance between the projector of A and projector of B will give us the total distance of end projectors. So right now we can say that the A1 dash C dash B1 dash is our true length, and A1 C B1 is also our true length. A dash C dash B dash is our elevation length, and A C B is our plan length. So these are the projections of line AB, which have a midpoint and which is inclined to HP at an angle of 45 degree and VP at an angle of 30 degree. Now let's move on to next example. A line AB measures 80 mm in top view and 70 mm in front view. The midpoint M of the line is 45 mm in front of VP and 35 mm above HP. The end A is 10 mm in front of VP. Draw the projections of the line and find its true length and inclination with HP and VP. So the given data is line AB measures 80 mm in top view, that means the plan length of the line is 80 mm, 70 mm in front view, that means the elevation length is 70 mm. The midpoint M of the line is 45 mm in front of VP and 30 mm above HP. So midpoint M is 45 mm in front of VP, 35 mm above HP. So midpoint M is in the first quadrant. And the end A is 10 mm in front of VP. So A is 10 mm in front of VP. Draw the projection of the line and find its true length and inclination with HP and VP. So we have to draw the projection, that means we have to draw the plan and elevation length of the line, and we have to find out the true length of the line, TL, and inclination of the line with HP and VP, that means theta and phi. So let's try to solve this example by using this particular data. So first of all, draw XY reference line. Now again, we are not going to mark any point, that means we are not going to mark the plan and elevation of any given point. Right now we will draw the locus only. So midpoint M is 45 mm in front of VP, that means 45 mm in front of, that means 45 mm below the XY reference line. We will get the locus of M, and it is 35 mm above HP. So 35 mm above, that means 35 mm above the XY reference line, we will get the locus of M dash. So on this locus we will get M dash, and on this locus we will get the M, which is plan of point M. Now A is 10 mm in front of VP, so 10 mm below the XY reference line we will get the locus of A. So on this locus we can mark plan of point A. Now PL is 80 mm, that means we can say that plan length is A and B, which is equal to 80 mm. So if we measure A to M is equal to 40 mm, and if we measure M to B, it will be equal to 40 mm. And the elevation length is 70 mm, so it is A dash, M dash, B dash. So if we measure A dash to M dash, it will be equal to 35 mm, and M dash to B dash it will be equal to 35 mm. So right now we have locus of A and M both. We have locus of A and locus of M both. So if we mark A on locus of A, and if we give arc on locus of M having length equal to 40 mm, we will get the plan of point M. So from A as a center and radius is equal to 40 mm, which is the distance between the plan of A and plan of B. Give an arc on the locus of M. So here we will get plan of point M, connect A to M. This is the half plan length, and if we extend this length 40 mm in the same direction, so here we will get a plan of point B. So this will be our locus of P and B1, and the length A and B is our plan length, and the angle of the plan length is beta. Now we have already done with this data plan length. We have marked the midpoint M, or we have drawn the locus of midpoint M and point A also. Now the remaining data is elevation length. So we will try to find out the elevation length. So for if you want to find out the elevation length, we have to find out A dash, M dash and B dash. So for that, first of all, draw the projector from A and B. So these are the end projectors of the line. This is the projector of A, on which we will get A dash. This is the projector of M, on which we will get the M dash, which is the elevation of the midpoint, and this is the projector of B, on which we will get the B dash. So right now we have the locus of M dash. So on the projector of M, we will get M dash on the intersection of projector of M and locus of M dash. So exactly over here we will get the M dash. Now as we have discussed that the distance between A dash to M dash is equal to 35 mm and M dash to B dash is equal to 35 mm. So measure 35 mm on the rounder, take center at M dash and give an arc on projector of A and projector of B from M dash having length equal to 35 mm. So give an arc on projector of A and projector of B. Here we will get A dash and B dash, and by connecting A dash, M dash, B dash, we will get the elevation length. So draw the locus of B dash and B1 dash, draw the locus of A dash. This is the locus of M dash, and this will be our elevation length A dash, M dash, B dash, and the angle of the elevation length is alpha. Now we have to find out the true length and true angle of inclination of the line with HP and VP. That means we have to find out the TL, true length of the line, and we have to find out the theta and phi angle. So if we want to find out the true length, take center at A dash, radius is equal to A dash to B dash, give an arc on or up to locus of A dash. Here we will get B2 dash, and from B2 dash draw a straight line up to locus of B. Here we will get B1. So this will be our B1, and by connecting B1 to A, we will get the true length, which is inclined at an angle of phi to the XY reference line. So phi is the angle of inclination of the line with the vertical plane. Now measure this AB1 length, which is our true length. Take center at A dash and give an arc on locus of B dash or B1 dash. So here we will get B1 dash, and by connecting B1 dash to A dash, we will get the true length, which is inclined at an angle of theta. Now we have fixed the A dash, so we will get the M1 and M also. So on the true length at the intersection point of locus of M, we will get M1, and on true length at the intersection point of M dash, we will get M1 dash. So now we can say that this is locus of M dash and M1 dash, and this is locus of M and M1. Now we have true length theta and phi. So measure the true length. True length will be equal to 98 mm. Measure theta angle will be equal to 35 degree. Measure phi angle will be equal to 44 degree. So this will be our final answer. Now let's move on to next example. A line AB has a point P on it such that AP is to P, B is equal to 1 is to 2. The end A is in the first quadrant and it is 20 mm above HP, while the end B is in the vertical plane. The point P is 35 mm from HP. The line is inclined at 30 degree to the horizontal plane, and the elevation length of the line is 70 mm. Draw the projection of the line AB and the point P. Find the true length, the plan length, and the inclination of the line with the vertical plane. So the given data is a line AB has a point P on it such that AP is to PB is equal to 1 is to 2. So AP is to PB is equal to 1 is to 2. That means PB is equal to 2 into AP. So if we measure P to B, it will be twice than the AP. the end A is in the first quadrant and it is 20 mm above HB. So the end point A is in the first quadrant and it is 20 mm above the horizontal plane, while the end B is in the vertical plane. So the end B is in the vertical plane. The point P is 35 mm from HB. So point P is 35 mm from HB. So either point P will be above the horizontal plane or it will be below the horizontal plane, that we have to assume. The line is inclined at 30 degree to the horizontal plane, and the elevation length of the line is 70 mm. So the elevation length is 70 mm and line is inclined to the horizontal plane at an angle of 30 degrees. So theta is equal to 30 degree. Now we have to draw the projection of the line AB. That means we have to draw the plan length and elevation length of the line, or we have to find out the plan length and elevation length of the line, and we have to draw the projection of P also and find the true length of the line. That means we have to find out the true length of the line TL, the plan length of the line, that is PL, and the inclination of the line with the vertical plane, that is we have to find out the phi angle. So let's try to draw the example. So first of all, we have to assume the point P, because it is given that P is 35 mm from HB. That means it is above HB or below HB. So let us assume P is 35 mm above the HB, or P is in the first quadrant. So if we assume P in the first quadrant, it will be above the HB. So P is 35 mm above the horizontal plane. So assuming P in the first quadrant, let's try to solve this example. So first of all, draw XY reference line, and after drawing the XY reference line, first of all we have to draw the locus of P, locus of B and A. So A is 20 mm above HB. So 20 mm above the XY reference line, we will get the locus of A dash. B is in the vertical plane, and as we know that if any point is in the vertical plane, we will get the plan of that point on the XY reference line. So XY reference line will be our locus of B and B1. And P is 35 mm from HB. Now we have assumed a P in the first one, so P will be 35 mm above the horizontal plane. So 35 mm above the XY reference line, we will get the locus of P dash and P1 dash, because we are going to fix end point A on the line. So we will get B and B1, and we will get P and P1 also, that is P dash and P1 dash. Now other data given is elevation length is 70 mm, theta is 30 degree. So let's try to solve this example. So first of all, mark A dash on the locus of A dash. So this will be our A dash. Now from A dash, draw a line inclined at an angle of 30 degree. Right now the length of the line is not known, because if we draw the line at an angle of theta, we will get the true length. But right now true length is not known. So let's try to find. So from A dash, draw a line inclined at an angle of 30 degree, which is theta. So the intersection of this line and locus of P dash will give us the P1 dash. It is not P dash, it is P1 dash, because this is the line of the true length. Now here the ratio is given, AP is to PB is equal to 1 is to 2. So here it is written that PB is equal to 2 into AP. So if we measure A to P, and if we want to find out P to P, so P to B will be twice then the length of A to P. So right now take length of AP on the rounder, put your rounder on P and give two arcs, 1, 2. So at the second arc we will get P1 dash. By connecting B1 dash to A dash, we will get the true length. Now we have the true length. So the length between A dash B dash will measure the true length. This will be our locus of B dash and B1 dash. Now this is B dash and this is locus of A dash, and we have the elevation length which is 70 mm, and as we know that elevation length is A dash B dash. So measure 70 mm on the rounder, or 70 mm as an arc length. Take center at A dash and give an arc on locus of B dash. So here we will get B dash. By connecting B dash to A dash, we will get the elevation length, and the angle of the elevation length is alpha. Now we have elevation length and true length in the elevation side. Now we have to find out the plan length and the corresponding true length at the plan side. So let's try. So first of all, draw the projectors or end projectors of line AB. So from A dash, draw a line. Here we will get P dash. From A dash, draw a line. That will be the projector of A, and from B dash, draw a vertical line. That will be the projector of B. So on this projector we will get the plan of point A, and on this projector we will get the plan of point B. Right now if you see that this is our locus of B and B1, so the intersection point of the projector of B to the XY line will gives us the plan of point B. So this will be a plan of point B. Now measure A dash B dash, or take A dash as a center and radius is equal to A dash B dash, give an arc up to locus of A dash. This point will be our B2 dash, and from B2 dash draw a straight line up to locus of B. So here we will get B1. So B1 and we have get B and B1. B is the plan of point B and B1 is the corresponding plan of B on the true length. So now we have true length A dash B1 dash. So measure A dash B1 dash on the rounder, take center at B1 and give an arc on the projector of A. So here we will get A. By connecting AB, we will get the true length. So this is our locus of A. This is our true length at an angle of phi. And connect A to B, we will get the plan length also. So this will be our plan length at an angle of beta. Now we have true length, plan length and phi, but still we have to find out the projection of point P also. We have get P dash and P1 dash, and if we want to find out the P, draw the projector of P from P dash. So this will be the projector of P, and the intersection point of this projector to the plan length of line AB will give us the P, which is the plan of point P, and from P draw the locus of P and P1. So the intersection point of this locus to the two length will give us the P1. So this will be our locus of P and P1, and these are the projector of P, that is P dash, P1 dash, P1. Now we have true length, we have plan length, and we have phi. So measure true length by using the scale. We will get the true length is equal to 89 mm. Measure the plan length, which is AB, which is equal to 77 mm, and measure the angle phi by using the protractor. You will get the phi angle is equal to 38 degree. So these are our final answers. So this is it for today. We are ending our chapter here. So thank you for watching me today. We will come with a new topic in our next lecture. Till then, take care.